So, okay, I think we are good to go. Again, for all the people that are joined, so welcome to the EclipseStore fundamental training. And it's a great pleasure for me to see totally different people as usual in that training, but it's mostly the case after a JCon or any other convention. So this is really great. So welcome for all the new joiners, I have to say. The very first important information, this training will be recorded and you will also get access to the recording or to the video at the end. Normally, it takes us 1 week or 1.5 weeks to cut everything and to prepare the video, and then you will get access after. So let me introduce myself a little bit. My name is Kuemmel. I'm Java developer basically, and I'm also involved in some further projects, I have to say, especially in the microstream cluster development, but also involved in some Allianz and Fraport projects. And mostly I'm doing the trainings, and I'm also doing some conference speaks and so on. I think Marcus will introduce itself. That brings me directly to the timetable. We have 4 hours in total. Somewhere in the middle, we will have a short break for about 15 minutes. Marcus will start with lesson 1, short introduction about EclipseStore for 45 minutes, and also some announcements. And after then, we will start with directly coding and get into some further stuff. Some informations before we start. So material. So as I already mentioned, you will get access to the recordings, and you will also get access to all the code repositories of that training. So before we go or we step into a new topic, at the beginning I will share the GitHub link to the project with you. So most of the projects you will be able to code along with me. So most of the projects have different branches, and you could start on any branch you want. If something goes wrong, just switch to the new branch and start from that point. Important is ask as many questions as you can, and whenever you want, just type it within the chat. So maybe Marcus will answer it, or I will stop from time to time checking for some new questions, and I'm trying to answer everything. So, oh, come on. So some links I want to share with you. So upfront, that means just a second, I prepared this for you. So some links are incoming. So you will see some links in the chat. Let's start from the beginning. So first you see the EclipseStore GitHub repository. There you will find a lot of different examples and information projects. Then we have the link to the EclipseStore documentation. That's also quite important. Most of the training is oriented on that documentation, so you could also read everything after within that doc. And also my GitHub repository, there you will find all the training examples. This is all the stuff that we do during the training. And last but not least, you will get a certificate. You have to register on cloud.microstream.one. So we have to create an account there, and then you will find, so just a second, I can also share this with you. So cloud.microstream.one. And just a second. Yeah, you need to sign up there. So that's the cloud front end. You need to sign up here. And that's important with the same email address you took part to the training here. That's important. And then you will find a certification section here. And as I said, it's the same like on the videos. It took us normally 1 week or 1.5, and then you will see your certification here. So click on that I here, then you can download your certificate. Okay, so great. So people are still joining. Okay, so I need to let them in. Okay, so that brings me to the topics for today. So as I already mentioned, we started with some introductions. Then I will have a short, quick demo for you. So that's the moment where you can lean back and just enjoy what happens on the screen. After that, we will do a step-by-step configuration. And this is the first point you can code along with me. So we go through different branches and we're doing a EclipseStore configuration step-by-step based on a Micronaut application. Then we will have some CRUD operation examples, how to store things, how to handle things with EclipseStore. And then we have some smaller topics after the break, creating a proper data model. And if we have enough time, I'd like to share a performance demonstration of EclipseStore compared to PostgreSQL. This could also be very interesting to see, okay, what the amount of RAM we need and the amount of CPU and so on. That's quite interesting. And then we have an optional topic, which is querying with Java streams. And this is the reason why it's optional. It depends on your knowledge. Most of you are, of course, already Java developers, and most of you are aware of Java Streams API, but some of you might not. And that's the reason why this is an optional part. So if you have any questions regarding Java Streams, feel free to ask, and then I could go into a smaller section of streams. Yeah, I think that's okay. But I will share a project with you where all that stream stuff is covered in, so you could have a look after. Then we have to talk about lazy loading. So the reason why we not want to have all the data all the time in the RAM, so we need lazy loading. And last but not least, there is an UI, a client UI to see what's going on in the storage. And we have to talk about legacy type mapping. So that means what happened if something changed within our classes. So that is called legacy type mapping. Okay, these are the topics for today. And that brings me to Marcus. So let me hand over to Marcus. Marcus, welcome to the training. It's your turn.
Thank you, Christian, for your kind introduction. I cannot share my screen.
Now you should be able to.
Okay. Hello, everybody. Welcome to our training for today, and thanks for joining. So this is very international. When I have a look on the attendees list, so more than 50 people were enrolled for the training course. Maybe there will be some people joining through the training. So welcome, good evening or good morning, wherever you are. So this training is all about EclipseStore, but not only EclipseStore, because I have some very exciting announcements for you. So there are great news. But first of all, let me introduce myself briefly. So my name is Marcus Kett. I'm CEO and co-founder of MicroStream. And with my team, we have been working for more than 15 years on Java development IDEs, especially on the Eclipse IDE. So we worked on a visual Java IDE, and there we were working on the JBoss Hibernate tools for Eclipse for more than 8 years. We have tried to improve and Hibernate programming with Eclipse, and so this was the starting point for EclipseStore more than 10 years ago. So this is about the history of the project and where we started from. So we are also part of or a member of the Eclipse Foundation. So we are contribution member. And within the Eclipse Foundation, we work together with great companies, with great committers on open source projects. And most people know the Eclipse Foundation from the IDE, of course, but it's not only the IDE. So within the Eclipse Foundation, we run more than 100 open source projects, and it's still growing. And there are famous projects like specifications like Jakarta EE, microprofile specification, but also very popular frameworks like Eclipse Link, the OpenJ9 JVM, and also work on JDK. Glassfish is very popular. And so there are many open source projects, and EclipseStore is also one of these Eclipse projects. So you can explore more projects on the Eclipse website. So this training is all about EclipseStore, and EclipseStore is all about storing Java object graph, but also Java performance. And so there are different reasons why EclipseStore might be interesting for you guys. So there are people who are interested in the incredible performance, but actually this is not the performance of EclipseStore. This is the performance of Java. And many people are interested in just storing data, processing data way easier than it is with object relational mapping framework like Hibernate. So there are different reasons why EclipseStore might be a cool project for you. Let's talk about performance. So when we when we started working on EclipseStore, then we were thrilled by the performance. Of course, the performance of Java, and it's everything that we build in Java is executed obviously in memory, and this is executed extremely fast. So here we talk about microsecond response time, microsecond execution time of a algorithm, or when we search and filter with Java streams in memory, we also talk about microsecond search time. This is really extremely fast in comparison with a database, a classic database. And it's because when we talk about performance of databases, we talk about milliseconds. So, and which means everything that's executed in memory with pure Java is up to 1,000 times faster than a comparable database query. And with Java, we also have already a multi-model data structure. And so we have many discussions constantly with Java developers, even with Java developers. And it's all about is the Java object model more powerful or more flexible than a database model? So you can check this out. So with Java, we are able to use, of course, any Java types. We can use collections. We can deal with a complex data structure like graphs with circular references. We can also deal with documents like JSON, XML. We can deal with vectors. So everything is possible with Java, and it's because of we have this native Java object model. That's great. We can, as I mentioned, searching and filtering on Java object graphs with Java Streams API. This is very cool because this is a very powerful query language. It's fully object oriented and extremely fast. So you get out the max of your JVM performance by using Java Streams API. There is also parallel streams for more complex cases. But yeah, when you search and filter on a really complex object graph in memory, mostly it will only take microseconds to navigate through an object graph, even it's really very complex. And so we have great language features. We have great performance with Java. And the only thing that's missing in Java, the only piece of puzzle that is missing is persistence. With EclipseStore, now we add persistence to Java. So this was the philosophy. With EclipseStore, we didn't want to invent another database, introducing its own proprietary data format or data structure. The big difference to all other storage solutions out there is really EclipseStore uses the native Java object model. So whatever you design in Java can be stored by EclipseStore. It allows you to store any kind of object graph, any complexity, any size, and you can use any Java types, and it can be stored. You can also use any Java concepts. You can combine it with any Java library, frameworks, everything that's available in the Java ecosystem can be used, and you can store it persistently on disk. You can store whatever can be recreated after it's stored. Of course, a thread cannot be recreated, but everything that can be recreated is can be persistent with EclipseStore. So Java native means there is no transformation, no mapping to any database specific structure or any other synthetic structure or format. We store object graphs by using the Eclipse serializer behind the scenes. The reason for that is the Eclipse serializer is able to deal with any Java types. You can store object graphs, any complexity of object graphs. So the depth of your object graph is not limited. It's way faster than the native Java serialization, and it's this is very important. It's highly secure. So with Eclipse serializer, deserialization attacks are impossible because there is no execution of code through deserialization. So this is very important for security and becomes more and more important in our modern world with more and more hacker attacks. So altogether, this allows you to store any object graph. So you can also store subgraphs. So in most cases, only the changes on your graph will be stored. So basically, it's possible to store the whole object graph, but in most cases, you will just store the changes. You store subgraphs, and you can also vice versa load subgraphs and restore subgraphs in most of the cases. So we will not load the whole object graph into the memory and restore the whole object graph. So we will mostly load lazy references by using the lazy loading concept of EclipseStore. Please, if you have any questions, comments, doubts, and so on, please use the chat. It's very important at this point that the functional principle is of EclipseStore is really clear. So the cool thing on EclipseStore is you can use pochos. So just plain Java classes. There are no, you don't have to implement specific interfaces like serializable. There are no specific annotations or external configurations. So just pochos. Very easy, no heavyweight dependencies. And EclipseStore is just a small Java library you can download via Maven. And the code is open sourced on GitHub under the Eclipse public license. So the EPL version 2.0. And this allows you to build also commercial software, so you can use it in commercial and closed source projects. This is allowed by the EPL license. So EclipseStore creates a kind of binary representation of your objects in memory. And when you store the objects, so mostly the changes are stored. It depends on you. So you as a developer decide when an object is stored. And of course, we recommend when you change an object, when you add a new object to your object graph, then store it, call the store method. And it's because of if your system will crash before you store an object, obviously the data is lost. So store your objects when you change or when you add a new object to your object graph or to a collection. Then you can use everything in this object graph. It can be you can have really a low complexity. The only thing you need is an instance of EclipseStore database in memory, and there is a root object, and all objects that are reachable from this root object can be persisted. So there's only a store method to call, and when you call the store method, then this is very important. Then this storage operation will be a blocking operation, and it will be transaction safe. This operation is ACID compliant. So we have a transaction journal, and it guarantees that data is definitely stored persistently on disk. And so Eclipse Serializer will create a binary file, will store it, append it to the file storage, and your file storage can be almost everything. You can use whatever can store binaries. So mostly, or the simplest case, of course, is you store your binaries in a file directly on disk. But you can also use a cloud object store like AWS S3, and we can also use, this might be um, a little bit strange, but you can also use a classic database to store your binaries, and it's because classic databases can store binaries. But keep in mind, there is no mapping, and there is no mapping of your objects to this database specific data structure or format. This is basically the functional principle. And Christian will jump in the code and will show you how this works. So from time to time, we had more developers telling us, yeah, there are some drawbacks. So because if classes change, then we might be in trouble. So how does schema migration work? We have solved this problem. Lazy loading was, of course, a big challenge. So do we have to load our whole object graph into the memory, our whole database to work with EclipseStore? No. We introduced lazy loading. You can load just some megabytes into the memory, and even if you have gigabytes of data in your storage. So this is also solved. Then there were many people, and they had really concerns in terms about using Java Streams API. So it might be fast, but do I have to load my whole database into the memory to search and filter effectively on my data? And what if I'm looking for just a specific value in my database? Do I have to load the whole database in memory? We were like, no, you have to segment your data. You can do it very elegant, and it depends on you how you segment your data. But then we decided to introduce a new indexing concept with GigaMap. We introduced indexing and a map that provides fully automated lazy loading. So yeah, segmenting your data and organizing your data and building a proper data model is still important, of course, because if you build a bad data model, maybe it will become um, inefficient and slower than it would be with a proper data model. So Christian will show you how you build a proper data model. But with indexing, it will be even more simple and fully automated lazy loading. And this GigaMap was introduced by MicroStream as a commercial add-on to EclipseStore. But yeah, our first announcement today is GigaMap will be open sourced, will also become part of EclipseStore. And then you get an extremely powerful feature for working with EclipseStore on really big data sets, and you don't have to search and filter through the whole database. So you can use this off-heap bitmap index concept, which is really extremely fast. You'll be able to search billions of objects in just milliseconds. This is really a great feature. A lot of people constantly, the last years, ask for distributed applications. And it's because of when we started with EclipseStore more than 10 years ago, then Java monolithic applications were common. With cloud, of course, horizontally scalable applications came up, and stateless services came up, microservices. And so the need for horizontally scaling became bigger and bigger. So many people ask for distributed applications. And so we started building an infrastructure, an environment that allows you to deploy your EclipseStore application and run it in a distributed environment very easily. This environment provides you replication. It is a very convenient concept. Everything runs on Kubernetes. So this is the base. The only requirement is Kubernetes. And this also was introduced by MicroStream as a commercial software at the beginning. And now we will also open source this cluster solution, and which means together with GigaMap and the EclipseStore cluster solution, you will get the whole stack as open source and as a really powerful, complete stack for in-memory data processing to build really powerful in-memory Java in-memory data processing applications with just open source software. So the Eclipse, so the plan, our plan now is to launch a third Eclipse project, and so the project proposal name is Eclipse Data Grid for that. And this Eclipse Data Grid stack will contain EclipseStore. It will contain also GigaMap and Eclipse Serializer as a core of EclipseStore. We recommend of the OpenJ9 JVM. It's also an Eclipse project, but of course you can use any JVM you like. But we found out through the last 6-7 years that Eclipse OpenJ9 is very memory efficient and fits really great to EclipseStore projects and in-memory data processing because of its memory efficiency, and of course with in-memory data processing, so memory efficiency matters and the performance of the JVM also matters, and OpenJ9 is really great for that. So check this out. But as I mentioned, you can use any JVM you like, basically. So with the whole stack, you will get a solution that contains of the core Java features, which is the native Java object model. And by the way, if someone is wondering whether this is similar to distributed caches or in-memory data grids you already know on the market. The architecture is very similar, that's true. But Eclipse Data Grid and the same with EclipseStore, it uses the native Java object model. This is the big difference to all solutions on the market. We use the native Java object model. You can now replicate any Java object graph through multiple JVMs, through hundreds or even 1,000 JVMs, and can distribute a real Java object graph using any native Java type in this object graph, and you can replicate it and distribute it. You can use it as a caching layer. It can be, it looks like a caching layer. You can run it between your application and your existing database to accelerate existing database applications. But it provides you also ACID compliant persistence by using EclipseStore underneath, and which means it's not required that you use a traditional database, but you can. It gives you more flexibility in the future. And also maybe easier discussions with your database teams. The cool thing is when you build so in-memory data processing layer with Eclipse Data Grid, with Eclipse Store, you can also implement Java business logic. It's like you implement business logic in a database system, but databases, they have to provide database specific languages like PL/SQL, but you can implement any business logic with core Java. So this is really great and fits seamlessly in all of your Java enterprise applications. All right. This is the functional principle. Okay, so this can also be, of course, used for migrating from a monolithic system to microservices. Maybe you're planning such a migration project. Maybe you just want to replace your database. In most cases, you cannot build a new application for 2 years. It will take you some time to build a mission critical application. So you build it for 2 or 3 years or even longer. And at one point, you will switch off the old application and you launch your new application. This maybe will not happen in practice, and it's because the risk would be way too high. And so in practice, this is a fluent process. And using Eclipse Data Grid is perfect for this use case. So you can run it in between your legacy application and your existing database, for instance, and then you can migrate service by service. And this will be a fluent process, and you can run both applications in parallel. So your old legacy application and your new microservice application. And of course, there has to be implemented kind of synchronization process. But this solution, Eclipse Data Grid, is really a great fit for these migration projects. You can accelerate existing database applications or use EclipseStore for replacing Hibernate and your traditional database. It depends on you. So the original use case was, and our intention really was to replace Hibernate because we had problems with our Java IDE. So we wanted to invent a persistent that is Java native, feels like a feature of Java, and it can replace Hibernate and relational databases. You can deal with Java native features. This was the intention, and also get out the max of speed of the JVM in-memory data processing with pure Java to reach microsecond processing time and search time, response time. And this is what EclipseStore and the Java native features give you, as I mentioned. But now you can also run it in between your application and your traditional database to accelerate existing applications. I like to mention further courses. So there are further courses provided by JavaPro, and if you like our courses, then please enroll for further courses and share it with your team members. And so last but not least, please give us feedback, ask questions. So Christian is one of the project leads. He is one of the people who write the code. So if you have technical questions, take the chance, give us feedback. Also, if you have concerns, if you think, wow, this can't be happened, can't be true. It seems to, in my opinion, in my experience, database stuff is faster, is more convenient, is so let's discuss. So let's keep this really interactive. And we will try to answer quickly and answer all of your technical questions. Now I'd like to give give back to Christian, and yeah, I wish you a great evening and fun with the EclipseStore training tonight. Thank you.
Yeah, thank you, Marcus. So now you should be able to see my screen. It's time for code, I would say. Just check if you could see my screen in good conditions. Letters are well sized to you. Okay, let me know if something is wrong. So, okay, great. Yeah, just some short informations about the hands-on coding for later. You will need some or any IDE of your choice. That's all you need. Java 11 up to whatever 21. I have to say it's good. Most of the projects you only have to check out from my GitHub, and they will run. Some details will follow. So, but now it's time to lean back, as I promised, and we start with one of the easiest usages of EclipseStore, and I prepared a small basic example here on the left, and it only consists of one main class. And when we jump into the POM XML, we see that there is only two dependencies which are needed to run EclipseStore. It's the storage embedded, and it's the storage embedded configuration. To be honest, the version is a quite old version, but this doesn't matter. It runs forever, I have to say. The newest version is 2.1.3, I guess. And yeah, feel free to use the newest version. But for the training, I'm not able to upgrade all the examples every time. So that's why. But it runs great, and that's okay. So let's move back to the main class. So the dependencies are in place. Oh, let me just comment that dependencies. The storage embedded is the main dependency, and the second one is needed for some configuration stuff. Especially for that example, it's not really necessary, but for you, it's important to know these are these are the two major dependencies you will need when you use EclipseStore, and that's it. Okay, so now jump back to the main, and yeah, let's move on a little bit. So let's start on line 7 here. That is oh, come on, what's okay, so let's enable this. So we need the first object that is really needed. It's our embedded storage manager. I would say it's the main object of EclipseStore, kind of like the database management system, the management object. This is always needed, and as I said, the easiest way to initialize it is calling embedded storage.start. That's it. So we always need one object as an entrance object to our object graph, and this is the root object. We call it root. And in this case, as I said, it's the easiest example, and I only store one string. That's all. If this makes sense, it's up to you, but it's the easiest way to store something. So then we we added that string, and now we have to call a store root. So this is one method. Just to mention this, it's not always best to call this method store root, but in this case, I have to store the root because I changed it, because I added a string. And that's it. So let's storage manager root. Yeah, let's enable that system out print line, and that's it. So let's check what's going on when we start this. So right click, run as Java application. Maybe I have to do a Maven update before. Yes, I have to. Just a second. Stop this. Makes more sense. Okay. So basic example, data storage, just to don't need this anymore. So now we are good to go. So run as Java application. Okay, and of course I have to shut down the storage manager. I forget this, but no worries. This is okay. So I stop the application. And when I now refresh the project itself, you see there is one folder or one package is created, which is called storage. This is the default package. And by the way, it's not the recommendation to store your data within your same project, but in this case, I tried to keep it as simple as possible. So I used the default, and you see after starting the storage, you see that there are two different objects are created. One is the persistence type dictionary. As the name says, it's a dictionary that holds every object type within your storage. So whenever you store something, like let's say a customer object, for example, it will be managed in that persistence type dictionary. It's a quite important file. You should not lose it. And then at the same time, you see that the channel folder, and the channel folder represents the storage itself. So there could be multiple channel folders for multi-threading, for multi-threaded writing to your hard disk, for example. Therefore, we will be able later to add some more channels to having a multi-threaded writing to your hard disk. Okay, so let's move on. So now Hello World should be in, and that's it. So let's keep it as it is. So let's remove this again. So we no longer need this anymore. Yeah, let's do it like this. Okay, so let's move on to the next lines. Let's create a more extended example. So we have a company object here, and in that case, company is my root object. That's also an interesting point. People always ask, do we need a synthetical root object as an entrance, or could it be also a business object? So in that case, we are using my company as a business object. We need to do an import. Then we need to create an embedded storage manager again. And in that case, we using a different path here. So data, let's call it data. Then we need to have two additional elements of customer or some customer pojos here. Let's jump into the one of that customer here, or in that customer pojo, and you see it's just a normal, straightforward customer pojo with name, mail, first name, age, whatever, a constructor here, and some get and set methods, and that's it. And for those of you who work with Lombok, for example, EclipseStore is also working with Apache Lombok, no problem. So you could use it. So let's move back. So we have those two customer objects, and now when we need to store these customers somewhere, and this is where the root object comes into play. So let's jump into the My Company class, and there is some code left from the last training, so it's totally enough to have this. Okay, so we need some collections here, and my main collection for customers is, so we do not need authors here, so it's totally okay to have a collection customers here with some get and set methods. That's it. And let's jump back. So, and that's the reason why we adding our created customer to this list of customers. So we're using the add method. And now there is the first very important situation here when to work with EclipseStore. Normally you are used to store or you are used to call a save or a store method, whatever, based, and then you have to hand over that object you created. For example, when you use Hibernate, for example, and you create a customer object and you want to store it, you always used to call, let's say, repository.save and then hand over the customer. And this is really different on EclipseStore, and I would say this is one of the most made mistakes people using EclipseStore. They try to store the object which is created or whatever, but on EclipseStore you always have to store the reference holder of the object. So that means we added customer to the collection of customers, and based on that we changed the collection itself. And that's the reason why we have to store the collection. And that's also the reason why we call store and we hand over mycompany.getCustomers, because we changed the reference holder, and this is what we have done, and that's okay. So let's give it a try. So let's save this and let's run this as a Java. Oh, again. So let's enable this and maybe an update just to be sure. Okay. Okay, so now we should see the data folder here. It's created here with the same files again. And now we will do it different. So we do not need the customers anymore. So something went wrong with my how to comment it out. So then I'm able to, yeah, let's do it like this. So we do not need these lines anymore. So we just need our company root object. So that must be still in place. So we need a storage manager, and the storage manager need to know the root object. So we have my company here, and the storage manager starts with the root object my company. And we do not need that store method anymore, but we need to have a sysout to see that our customers are in the storage, and that is it. That is okay for now. So let's start this, and now we should see these two objects down here. So yeah, you see that here are the two different, or even four, because I started it 2 times. So that means we have 2 objects here in the storage, but you see there is the John Doe and the C Kuemmel in the storage. And that's it. That's the easiest way how to use EclipseStore. There is one storage, there is another, there is one JVM, and that JVM accesses the storage. We had that question earlier, if it's possible accessing one storage example, for example, the data folder here, accessing this with multiple JVMs, and this is not possible. And it is a little bit also on purpose, because also in the past we would never recommend to access one database from multiple different applications, and it's the same here. But we always recommend to provide the data at the end via REST to all the consumers that can use that object. Okay, so as I said, that was the easiest example of EclipseStore. Any questions so far? So directly at the beginning, are there any questions? Feel free to answer. There is one answer here. Would store my company also work? That's interesting. So let me jump back to the code a little bit further. So you mean to store only my company, and this will not work. There are some reasons for that. I will come to that reasons later why this is not working. You mostly have to store the direct reference holder instead of objects on top. Maybe a short explanation before I come to that on detail. It's an appending storage, and it's recommended best practice not adding too much always to append this. There are possibilities to store some objects above, but then that means at the end you attach bigger objects than needed at the end of the storage. So as I said, it's an appending storage, and there is an housekeeping process working in the background to delete all the duplicates at the end. But this is more detailed stuff for an advanced training. You saved twice accidentally. That means at this point we cannot distinguish that the instance is already saved, right? No, you cannot. At that moment, you create a new instance and you add it to the collection. It will be stored. In that case, you have to work with a set instead of a list, for example, using some equals methods and so on. That's totally on you. And you also have to take care about using unique constraints. For example, you could use any Java functionality on that, but this is also a part that comes a little bit later. But you have to deal with that, yeah. Okay, so. Yeah, there is a possibility to see what's going on in the storage. It's also a topic for a little bit later. There is a REST interface you could enable on startup, and then you will be able to access the storage via a second application to see what's going on in and to see what is stored. The point on that is the data structure is, I have to say, it's totally different to a relational structure. So you will have tables and so on. At the end, when you look into the storage, you will see that it's a totally different structure. It's a hierarchical structure, and it looks different, but you will be able to see what's going on. Okay. So then I would say let's start with the first project and the part for your hands-on. So if you want to code along with me, feel free to do. Let me just share with you the project. The project is a step-by-step configuration project. It's a Micronaut application. So let me just share the link with you. So that's the link for the checkout. And just use the ID of your choice. Check out that project here. And we will start at the branch. The branch is called step-by-step configuration. Let me just double check team, switch to, beginning is the name of the branch. Step-by-step configuration 1 beginning. So that's where we can start together. Let me just close this one. I don't need the old project. So I decided to use Micronaut at this point. It's only my personal decision why I decided. You could also use Spring or whatever framework you want to use. It's totally up to you. For me, it was okay for having an application that I could call REST endpoints, for example, to see if everything works. Otherwise, I had to use some UI stuff and for the training, and therefore I decided to use Micronaut. And another point is it's not, I would say it's not the best way or not best practice how I implement these things into Micronaut. I'm also aware of injection and so on, but I tried it to keep it as simple as possible, and therefore you will see things that are not properly implemented, but it's just for the training. I tried to keep it as simple as possible. Okay, so just check out the project, the branch I already mentioned, step-by-step configuration 1 beginning. And when we have a first look into the project, you will only see a package with application in it. Let me just check. Yes, there is. Maybe is the dependency is not there. Okay, so yeah, that's okay for us. So I have to delete the data folder. Okay, now we are ready. One important thing you have to do before is you have to enable your annotation processing. On Eclipse, I can show you where to enable this, and I think it's the same on the IntelliJ IDE, for example. Let's go to the settings or preferences in EclipseStore, and you will find it on the Maven section. When you go to Maven, you will find the point annotation processing, and you should choose experimental or automatically. That's on you. Both will work at the end. But this is a necessary step to run the application then. Okay, so when you check out the project, so we could give it a try if the application would run. So just move to the application class here, and on Eclipse right click and say Java run. So that is basically working, but I need a Maven update first. You could also use the command line for starting that Micronaut application. That's on you. Yeah, and then it should look like this. So you should see the Micronaut and also the startup is completed, and you should see application is running on localhost 8080. So that's the basic preparation for the project, and then we could start with so yeah, that's because I updated things from time to time, and and sometimes I forget to update, but it's on you. Use 11 or 17, it's totally up to you. No differences with that. It should work on both. So, and the first step of success should be when you see that the application runs, and that's okay. And based on that, we could enter some additional code. So the first thing we have to do is we have to add the right dependencies, and therefore let me just switch to my second screen. It makes it easier for me to do all that stuff live. So let's add the dependencies to the POM XML. That's the first step. So let's jump into the Maven POM XML and let's add the new dependencies to the end. And yeah, as I said, the newest version is 2. Oh, let me just double check. I guess 2. Getting started. 2.1.3 is the newest. 1.3. And we will use the same on the storage embedded configuration. So you will also see a different type of of configuration now in that example. I promise you there are multiple more way to initialize a storage, a EclipseStore storage. It's based on an XML file. You could use a YAML file. There is a special integration for Spring and Micronaut and some other applications. Several different ways to initialize, and next we will see here in that example. Okay, so we need these two dependencies. Let me copy this to the chat, makes it easier for you maybe. And just grab them, enter this, store it, whatever, and we are good to go. Okay, so the next thing we have to do is we need one class where all the static stuff will be available. And therefore, I'm using creating a new class in the same package like the application here, and I call it DB. And I already mentioned this. I'm using a lot of static stuff now. It's not the right way doing this, but it's the easiest way, I have to say. And the first thing we need is our embedded storage manager. So let's initialize one. So let's say static. Let's call this embedded storage manager. And let's give it a name. So let's call it storage manager. That's okay. First object, which is an important one. Later on in some special implementation of Micronaut, you just have to add one line to the YAML file and or to the property file that enables you to just inject the storage manager on the class where it's needed. But for now, it's totally okay to use it this way. Another object we need is our root object. And yeah, I think we should first create that root object. And in that case, we creating a new Java object. Let's create a new class and let's call it data root. Instead of having a business object, as an example, in the previous example, we used the company. Now we use data root. And the data root covers all the collections we need within our object graph. And some of you might ask, okay, could I have multiple roots, for example, or could I have multiple storages in one project? Yes, you will be able to have multiple storage instances within your project. So that means feel free to create as many storage manager as you want, and each one could write data to a different location or whatever. So that's possible. And based on that, it's not really necessary to have multiple roots. Having multiple roots is also possible, but to be honest, I've never done this before. If in that case I need a second storage, I always create a second storage manager, but it's also a rare situation having that. Okay, so I created a data root file here, data root class, and that's enough for now. That enables me to instantiate this data root also in a static way. So let's call it public static, or let's do it more precisely. Let's call final static data root. Here we are. Let's call it root equals new data root. That's it. Okay, so nothing special so far. Let's add a static block for doing some further initialization. of the two objects above. And let's say, let's say storage manager, come on, storage manager equals. And now this is the instantiation, the manual instantiation of an EclipseStore, of an embedded storage manager is always the same. So first we need one configuration object. So we started with embedded storage configuration, and that object is available at that moment you add the configuration dependency. That's why we added the second dependency to the POM XML. So embedded storage configuration, and that configuration object provides us a builder pattern, and let's call it builder dot. And now, based on that, we are able to do a lot of different configuration stuff. And one is to define the place where to store. So that means I'm using set storage directory. And we say, let's use data. So this is the moment where people mostly ask, okay, what is best practice, where to store the binary part? And I have to say, it's totally on you. But in our project, we are mostly used to, because we are using Kubernetes or Docker or whatever. And then we are mostly using persistent volume, for example. And but also an AWS S3 bucket is possible, or your relational databases are also possible to store directly into your relational database. At the end, you will get the same data structure or the same binary blob also in your database. But yeah, the best practice approach I would recommend is storing directly to a persistent volume or to your server, whatever. It's the fastest way. So, but it's not only on performance, because EclipseStore is mostly an in-memory database. So at that moment, EclipseStore starts up, it loads the data from the storage, and then you will not have any communication except the store. So that the store will take longer than if you work with a remote storage, of course. Okay, so set storage directory, and we call it it's data. And based on that configuration, we creating another object, and we create an embedded storage foundation. That's always a step in between. So we have the configuration, then we have, based on that configuration, we create a foundation. The reason why that is at the beginning of the framework, we had different layers in between to set up some configuration stuff. During the evolution of the framework, now we will be able to configure everything on the configuration layer. That's okay, but the foundation layer is still in between. So based on the foundation, we creating the embedded storage manager. And here we directly hand over the root object. So let's say root. So it's the instance from above here. And you should never forget, that's important, never forget to start the storage. That's important. And I did it. I forget it a lot in the last few months or years, and it leads to a weird behavior of EclipseStore, and you're wondering, okay, why it is not working? I can't find the issue, and yeah, you should never forget to start. Okay, so let's check if there is everything in place. I guess yes. One hint from my side. So we talked about the different channels here, and there is one method that could be set channel count. See that? That enables you to add more channels. And let's set it to 4. It's important always using power of 2. So you could have 2 channels, 1, 2, 4, 8, 16, and so on. And that enables you to writing down data multi-threaded to the storage. So let's do so. Let's say set channel count 4. That's okay. You could also do this. A sweet spot of the amount of channels is, yeah, let's say something between 1 and 4. To be honest, I've never used more than 4 because it's fast enough. Maybe if you are dealing with a lot of big binary blob files, for example, and you want to store this to the storage, then it could make sense to have multiple threads for not blocking the write log of the system. And then it could make sense having multiple channels here, especially with bigger binary blobs. But for a normal storage we deal, it's totally enough to have something in between, something of 1 to 4. Okay, so with that class we are good to go. So at that moment we're accessing the DB class. It will be started up automatically. So we have to check if we need something in the data root file. It's still empty. So, but there are some objects still missing, and that brings me to the next step. And just a second. Okay, so let's create one package. Thank you, Marcus. Okay, right click and say we need a new package in the one microstream folder, and let's call this a domain. So let's create a domain package, and within that domain package we need a new Java class. Let's keep it simple. Create a book object. So now you should have, by the way, if you want to follow up coding, you could also switch the branch. We are now at branch number 5, create entities, create entity and register. So that's the branch we are currently working on. Or this branch is the result of what we will get when we are done here. Okay, so book object. So let's create a simple book based on, or has its ISBN in it. So private string, let's call it ISBN. And another one, let's call it private name, private string name. And private, oh, come on, let's do it right now. Let's add an author. That's okay. And let us help the IDE. So let's create that author, right? So come on, so let's create that author directly. But let's stay in the book class. And there was one question right at the beginning of the training. If we support, I hope if we support the normal Pojo model, I guess this answers the question. So we are dealing with pure Java objects, pure Java Pojos, nothing special in it. And yeah, it's, in my opinion, the best way doing that. Okay, so what we really need within that example, we need 2 constructors, and let's just shortcut. Here we are. Okay, so create some get and set methods. That's okay. We need And then we need the normal constructor. That's okay. And another one using the fields. And then we are good to go. So this is our book class. Nothing else is needed here, but we still need to add something within the author class. That is, this class is still empty. And here the same happens. We are creating 1, 2, 3 fields. So let's say private string mail. And by the way, I'm using strings now, but it's no difference if you're using integer or local date or whatever. It's totally up to you. You could add whatever you want, but it's just for the training. So string first name and last name. And you see the differences to a normal relational database right now, because this is always a question that people ask us. How about searching within EclipseStore, or how to find objects? Is there a query language or whatever? First of all, based on the object graph itself, it's much easier to access different objects because we do not have that long tables or endless tables with millions of objects in it. The object graph itself divides many collections into smaller ones. So that means in that case, for example, we are, of course, we have one big collection of books for now, but each book has its own author, for example. So there is no long list of authors in it. Each book has its own author in it. And that's the reason why we do not need that much SQL queries or Java streams anymore, because it's easier to navigate through the object graph and getting all the informations out direct from the graph. And that's why it is so easy and to work with EclipseStore. Okay, here the same. We need some constructors. Let's create one for the fields and also create some get and set methods. Oh, okay. Here we go. So that means we have, so just have a short look on that. Yeah, it's not mandatory, in fact. So I'm added it because of I have this one here, but it's not needed. It's not really needed. So let's try it out. So let's remove it. We do not need it really. So that's also okay. Let's remove it. And okay, so now we need to jump back to the data root, because we need a structure that covers our books at the end. And therefore, we creating a list, private final list, Java utils. Let's type it to book. Let's call it books equals new array list. Okay, here we are. And we also need get and set methods. Okay. This is all we need. Okay, so let me just double check. So the basic stuff is done. So let's go through. We have our DB class. There is an embedded storage manager in it, and we need one more. We have one root instance. We initialized everything. So also the root instance. So there is one collection within the data root. which holds our books. And what about the authors? Of course, each author is part of a book. So here we are. So here we have that author, and that's it. Many people ask us, okay, what about primary keys? Here directly, EclipseStore does not need primary keys anymore. And it's the same on foreign keys because EclipseStore using the Java reference model in the background. So it knows what objects belongs together or reference to each other, but you will still need some unique identifiers, of course. And in case of books, in our case, it's the ISBN. So this is a unique value which identifies a book directly. The only question is, what about the author? Well, in our case, the mail address is the unique identifier of an author, and that is one of the biggest, let's say, differences. We do not need synthetical IDs or foreign or primary keys anymore. Okay, how would you get all books by an author? That's an interesting question. One possibility would be having a list of books within the author, for example. So we could have a list, let's say like this, book, and so on and so on and so on and so on, you know. So this would be possible, but then you have to deal with this, or you have to take care about that these things are synchronized, you know. It's kind of like a bidirectional relation within Hibernate, for example. And it's the same here. You always have to take care about two sides and to fill these two sides to keep the cache up and running and keep the cache consistent. And it's the same here. You could have a list of books within your author object. And now you might say, okay, does that doubles the memory? It will not, because we dealing with references, right? So that means it's only a reference to a specific, or it's just a pointer to an object on the heap. And that's why you could define as many books as you want. Of course, the reference itself will need some memory, of course. And this is one solution how to get all books by an author. That's only one. There are several more by using the Streams API, for example, but I will come to this a little bit later. Okay, so we created author books application. What we finally need is a controller class. So somehow we need to access the data from outside. And that's why we need a controller class. So let me get into this. So we need a second package here, new, let's call it controller. So that's the possibility to access from outside. So one controller class. And inside that, controller package. And inside that package, we're creating a new book controller. So let's call this book controller. So, and this is pure Micronaut stuff. What follows now? So we need to add a controller annotation on top. So we need to say here add controller. So to enable all that REST stuff, I have to say, and we need an URL entry point, and let's call this books. So that means whenever we call localhost.8080/books, we are directly here at this point, and that enables us to call some further methods down here. And one method, and I need to speed up things a little bit, so I will copy paste you the next method, and I will go through this together with you. So a lot of stuff is now going on into the chat. So just feel free to copy paste the get method. So, and I will do the same. I will just copy paste this. We need to organize some imports. Oh, come on. So, HTTP response author, that's all the same. DB. Okay, let's go through that block a little bit just to make sure that you understand everything properly. So the /books is the entry point, and whenever we call /books/create, so we are right here, and that brings us to the point where we create some authors and books, and you see the author here is reused down here at the book, and it's the same on author 2. It's here. And what we now do is db.root. So db is the entrance point, .root get books. So we are getting the book collection, and then we add everything. And I shortened this a little bit, collection utils .set of books, book 2, 3, and 4. So that means we changed the collection of books. So we added these books, and that brings us to the point where we need to call the storage manager, db.storagemanager.store, and I need to store the book collection. And yeah, that's just one HTTP response, book successfully saved or successfully created. That's all we need. So last but not least, we need one more response or one more interface, and let's just use get here, and let's say public list, and let's say get books, or yeah, get books is the right thing here, and it returns just the collection of books. Really straightforward. So get create, here are the books created, and here we getting a list of books. And yes, I know you should never use the entity itself instead of using data transfer objects and so on. There are many things that needs to be fixed in that project, but it's all about EclipseStore and understanding how the storage works. So we had 2 questions, or one question. Would it be the same strategy for getting all books by author within the GigaMap? I would say yes. The GigaMap is working a little bit different because it has its own indexing within the GigaMap itself, but the GigaMap itself is working in the same way than a normal collection is working, and I will get into the GigaMap more in detail on the advanced training, but yeah, I would say all over it works the same. Okay, that's it, right? So we are good to go. So let's try it out. I will do a Maven update before. That will help do the trick. So Maven update project. So don't forget to enable annotation processing, and now the application should be available. So let's start it. Run as Java application. You should get the message server is up and running, localhost 8080. And now you can open a browser, and let's call localhost 8080 books, and you should get an empty result. And in the console, you should see the initialization of the storage manager. So you see creating embedded storage manager, the dictionary is empty or not existing. Everything is working like a charm, and we getting an empty result. of books. That brings us to the point where we need to create something. So let's create some books. We should get the message book successfully created. And when we now try to get the books again, you should see the well-structured JSON file that is returned from the browser. Sorry for that, but I disabled the JSON formatting stuff within my browser. So you could also use Postman or whatever the tool of your choice to call that. And yeah, 4 channels were also created. Exactly. So when we have a look on our data structure here, we see the different channels on our hard disk, channel 0, 1, 2, 3, and the type dictionary. So let's jump into the type dictionary for a short moment. So I promised you so the database is instantiated at that moment you're accessing the DB class. I would say, so when we call DB, so give me just a second. So it's here on the book controller. So when you, the first one, we tried to get the books, right? So that was the first call we did. And here we're calling db.root. And the reason is DB is a static class, or there are static elements in that DB. You see that here. We're accessing that class, and that's the moment where the database is initialized. Okay, so let's jump back to the browser. Here we are. So, okay, but so let me restart the application. So to prove that data is persistent. So here we are. So let's start the application again without storing before. So run as. And now we directly call books instead of calling the create before. And you see data is persistently available. And that's how it should work. Really nice. So normally live coding does not work that smoothly, I have to say. So any questions from your side regarding that? Does it work on your side? Any problems? So let me know if there are some problems. Thumbs up, yeah, great. Yes, it works. So then I have to say, congratulations. This is your first EclipseStore project. And it's, by the way, one of the most powerful storages on the market, I have to say. And I will prove this after the short break a little bit later. So one question is, what are the best practices for performance and memory optimized of the EclipseStore based storage? That's a huge question, I have to say. Of course, one of the key things is a good data model or a good data structure, I would say. That's the first thing you always have to consider. Then you should also be aware of what type of data do you really need in memory and what data could stay on the hard disk as long as it is needed. So yeah, I have to say it's also always the developer that needs to consider stuff. And we're talking about lazy loading a little bit later. That's an important part of EclipseStore. And to be honest, you do not have to take care about performance because we are working in memory and we are doing stuff in memory, and this is always fast as hell. And yeah, sometimes that leads a little bit to sloppy programming. That's also a big problem because performance is not an issue anymore. Everything is really fast, and that sometimes you have to be careful about that. So memory optimization. Let's talk about this a little bit later. Is EclipseStore compatible with GraalVM? Yes, it is. And it should always also be possible to use it to using GraalVM native image, but there are some things you have to be careful with. Yeah, that's all I can say because I'm not an expert at GraalVM, but I know there are some parts are a little bit tricky. Maybe if you need to know more about this, let me know by mail so I can forward it to my colleagues. They are better to answer this. What are the best practices for using housekeeping APIs? Housekeeping is the default behavior of housekeeping is so you should be fine most of the time. But there are some situations, for example, when we using heavyweight writing, for example, because you remember we are an appending storage. So that means whenever we call a store method, it's appended to the end of the storage. So when we now talking about heavyweight writing, that leads to the situation where data on your hard disk is growing more and more, and maybe the housekeeping is too slow or has too the resources are not enough for the housekeeping process to clean up everything properly. So, and that's maybe that forces you to update your housekeeping settings. This is possible, but most of the time you should be okay with the default settings. Okay, good so far. So let me just check my list of topics to not forget something. Okay, so let's move on to the CRUD operation, and that's the moment. This is the last topic before the break. There is one project which is called MicroStream CRUD demo team. Maybe update. So let me share this with you again, as always. So, so there's my repository. I always need to find my projects, so it's always hard to find. So here we are. Okay, so this is the next project we will work on. MicroStream CRUD operation. I already opened that project here. And you see, when you start on the normal master branch, there are two branches in that project. One is the CRUD implementation done. This is the branch where everything is working great and it's already implemented. And the master is where we could do the hands-on coding on that. And I want to start. So for the first part, I want to start with that. Maybe time pressures us a little bit to copy paste, but we will see. So so let's jump directly into the book controller because everything is already in place. So we have the database class already here. We have a data root, we have book authors and so on, and a book controller. So, and let's move on a little bit on create books. And this is really straightforward. We already talked about this, how to store things. So that means these mockup utils load mockup data, loads data from mockup down here. So some JSON files here, not that interesting for now, I would say, but it creates a list of books, and that's exactly what we need. So first step, we always using the db.root, the entrance to the storage, and let's get books and then add all, right? And then we are adding the load mockup data. So we should not forget what to store. It's always the same. So, but first we need db.storagemanager.store, and we always have to store the things we have changed, or the reference holder. So, and that's in our case db.root.getBooks, because we added something, and that's it. We are good to go here. That's already done. Nothing special here. So after loading the data, we adding the data to the collection, and then we store the collection. That's it. Quite easy. A single one to store a single element. I have to say it's the same like here. So yeah, let's skip this. Get books is always really straightforward. And now this is the part where it becomes more interesting. So it's getting more interesting. Give me books with an A. So, and this is the part where normally I would jump into the Java 8 Streams API and how to querying data and so on. And yeah, I give you a short impression here how to use it. But I think that's enough. All of you are, so you all are professional Java developers, and you should be aware of the Java Streams API, I'm pretty sure. And therefore, it should be an easy task for you to write code here. So let's get all books with an A. So we need to access the root. Oh, sorry. So let's, it's always db.root.getBooks. So let's stream through these books, and let's add a filter. So the Streams API always starts with a special keyword. I have to say it's the keyword stream. And after that, it allows you to do multiple things here. If you are interested in what's possible, I'd like to share another project with you, and I will do this right now to not forget it. Repository stream. Is it called stream? Yes, it is. So here we go. So it's just one project that consists of a lot of different types of streams. And it's not relevant for now, but maybe helpful for later reuse or reviewing some different streams if you are not aware or a professional in streaming things. So, but now let's jump back to the example here. So db.getBooks stream through, and during the stream we're using a filter, and let's create a book reference, and then we have to say b.get come on, get name dot starts with, and then we could add an A, for example. So, and now we need to collect the result, I always said, and that we could do when we call the toList method, and that's all we need. So give me the book that starts with A and collect all these books to a list. And the only thing we have to do it, we have to, oh, come on. So I'll assign to a local variable. So we have our list there, and now we could return the lists or that list. Okay, so nothing really special. If you are aware of the Streams API, that's quite easier. That is quite easy. A more interesting point is how to delete stuff. So how to clear the books again, and that is also quite funny. db.root.getBooks.clear. That's it. So we have to clear the collection itself, and you could guess the next line of code. Any suggestions from your side? We could also copy something from above. That's also possible. Of course, a store, but which one? So yeah, it's the same as always. we changed the collection because we removed all the books, and that leads us to storing this collection again. Okay, really straightforward, right? So nothing special. And that's also one of the big advantages when people ask us why to use EclipseStore, or it's not only the performance, it's the pure Java power, I have to say, keeping things easier of storing and stuff like that. Of course, EclipseStore does have its special things you always have to consider, but the easy handling is one of the biggest things. Okay, update a single book. So how could we do this? How to update a single book? Just a second. I always have to double check to not doing some weird stuff. So okay, so to update a single book, we first have to read to load one, right? So let's do this first. So we need to stream through. So db root get books stream, and in that case I'm just getting the first one, right? So that's okay for me. So that returns an optional, and that's why I'm using get, and I should be able to get the first book. So now we could change something. Let's say book.setRelease and use local date.now. And guess what is the way to store? Again, but now it's a little bit different because we changed the reference holder of the release date, and it's book. So in that case, we're storing the book. Easy, right? So nothing special. Last but not least, how to update multi-books. So let's create a method like this. So let's doing this. So we stream through the books we have, and we try to get, or we are getting all the books that starts with an A. It's the same request than before, or up somewhere there. And we're doing a for each on that. And now let's say we want to set the price of each book to the same value. So then we need, it's a big decimal, as far as I remember. So we need that line of code. So we're creating a big decimal value, b.getPrice multiply by a new big decimal by 0.9. So we multiply the value, and then we say b.setPrice value, right? And now we could do the same here. bb storage manager store, but instead of using book here, we should use b. So what do you think? Is that a great way of doing that? So let me just, some of your ideas would be great. Any one of you say, okay, this is not a good approach. What else could we do? Any idea from your sides? I will help a little bit. That store here on line 83 is a blocking request. So that means it blocks the it blocks the business logic, and because of that, it is an issue within that for each, right? So because this will run forever, I would say. So and of course there is one point that's thank you for that hint. How about transaction, right? So that's exactly the point. We need to find a different approach for that. Okay, so there is one. And let's do so. Let's go to the storage manager and ask him for a special storer. And there are two methods here. One is the create eager and one is the create lazy storer. Storing things lazy is the default value. That means at the beginning we talked about this when you ask for, is it always necessary to store, write the exact object which has changed, or is it possible to store one object above, for example? That's exactly what the difference is when we're talking about lazy and eager storing. So the lazy storer stores only the object which has changed, and only that object, not the sub-elements, for example, below, only that object that has changed. And the eager storer is a different one. The eager storer stores the whole object line and also all sub-objects below. Again, so just a second. Okay, so it's done. So, and therefore, for us, it's totally okay to use the lazy storer because the eager storer could be problematic in some way. So therefore, I would always recommend to using the lazy storer. But the great thing on that is, let's create one and let's call this lazy storer. Oh, come on, what's going on here? It's always hard to working on two different IDEs and never know all the shortcuts on, or if I forget. So storer, lazy storer equals. Now we are good to go. So, okay, storer. And we call it ls for lazy storer. And that gives me the possibility to say ls.store. And sometimes this behavior or that method store is a little bit misleading, I have to say, but it's not a store itself. It's more than a register. Register that object B for later storing. So this is working. But because then after the whole process is running, we could do something like ls.commit. And at that moment, we're calling the commit functionality, the books will be stored at the end. And that's the special thing. And that leads us in a way where we get, let's call it a lightweight transactional behavior. Yeah, let's do it so, right? So, and that also prevents us from blocking loops and so on. And that is working really great. A little bit further, when we're talking about transaction, we need some rollback mechanisms, but this is part of the advanced training. So I don't want to get into this that much. So you will be able to roll back within a try catch, for example. So whenever something went wrong here, you will go to the catch block, and then you will be able to do a rollback. And the rollback is, yeah, it updates the memory based on the persistence on your storage, I have to say. But this is the way how to update multiple stuff. So create a storer and let's register the object on that storer, and at the end you call a ls.commit. I hope that answers your questions a little bit. ls store is a non-blocking call. Yes, it is. Yeah, to be honest, I'm not really sure about this, but yeah, it does. It's a quite. It's just a registration on the memory, and it's quite fast. And if it's really non-blocking, or I don't know. So I have to ask my developers. But it's quite fast, so no worries about that. But the ls commit, it could be. Of course, it depends on if you're using a remote storage, for example, when you're storing to an AWS S3 bucket, for example, then ls.commit will need for sure longer than storing things to your binary storage, of course. Okay, so we are good in time, so feel free to answer whatever you need to ask. So it's totally okay. It's a great opportunity within a training to ask those things. There is one question I missed a little bit from Jose. Won't it be slow if I, for instance, search for the user by email in a base with 1 million of user using filters? To be honest, it's not the search itself that worries me a little bit, because it's so fast that will definitely do the job. It's more about having millions of users within a collection. So that means dealing with that in the RAM. So that's I would say it's more challenging having this instead of querying in that. And that brings me to the next topic, or to the next round, where we talk about lazy loading a little bit, where we talk about performance and all that stuff. And also, I want to talk about a little bit about data model. The topic data model, it's always interesting, or it's always hard to explain, because most of you are used to use Hibernate and some other technologies instead of using the pure object model of Java. So there are a lot of questions regarding how to migrate from Hibernate, for example, to EclipseStore, and how doing this. And that brings me to a presentation, a small one I prepared for you, just as an entrance point into the discussion of creating a proper data model. And it's the same on my side. So when I started to use EclipseStore in projects a lot, it was always a little bit challenging to create a data model that worked for me, because so there were some issues like performance, or maybe memory was a problem. And then other developers showed me some different possibilities to using objects in a different way, or for example, using a small int instead of an integer, for example. That works great for me when it comes to handling millions or multi-millions of data, I have to say. Using the small integer makes huge differences within the object model, and within also when it comes into memory. So let's talk about a little bit a project or object structure. Let's imagine we are a book selling company with multiple bookstores. We are selling thousands of books a day to our customer. What most important notes and tables do we need, and how the relations would look like? So, and I'm pretty sure every one of you is able to create an object graph based on that. For some of you, it might be easier to create a relational model based on that. So thinking in tables than in an object graph, right? So, but in the end, when we compare EclipseStore to the relational database, we always have to consider then, based on the relational database, we mostly have Hibernate or any other OR mapping in between. And this creates us an object structure, which is really similar to a normal object model. But yeah, let's get into it. So, okay, we have our company, which is the root object, right? So we already talked about this. And the company has multiple addresses, for example, or multiple stores, and also multiple customers, of course. And here you see things getting more interesting, because we have addresses here and we have addresses here. Of course, each store has one address or multiple ones. It's a detail, yeah, I wouldn't say it. So we have employees here in the stores, we have orders, for example, and we have books. And now we see, and we have also addresses here. So you see, and this is the point where it comes to the question is, do we really is it really necessary to have one huge list with millions of addresses? So instead of this, all the addresses are divided and are part of the different employers. And the interesting thought on that is that, for example, here, each employer is an index for few addresses, right? So, and that's exactly the point. You will getting automatically indices out of your object graph. So, and it's no longer necessary to search within millions addresses. Maybe there are some, corner cases, I would say. For example, books, right? So it could be possible having millions of books in one in one collection, but there are some things we could do better at this. But and that's and this is, you always have to think about both. At the end, EclipseStore feels a little bit in between Hibernate and the relational database. We are getting, we are using the best of both sides, I have to say. We are using the tables as collections, and but half the amount. And that's also a point. It's always hard to explain that half the amount, but it's let me just explain this. There is, we do not have that that amount of tables that we really need, because things are part of a parent object, for example, and therefore we do not need tables anymore for things, because it's an embedded element of a parent item, I would say. And on the other side, we are getting relations and fields and validation from Hibernate within our object graph. And it's kind of like when people ask me what type of data model they should use, it's quite hard for me to answer this, because I would always recommend and say, choose the right data model that fits best to your application. And this is one of also the big advantages of EclipseStore. Now, with EclipseStore, you have the chance to create a data model that fits exactly to your application and does not fit to your Hibernate or relational database. Then that is a huge difference. Normally, you have to create a structure that works with a relational database and with the OR mapper, right? So, and now it's different. Now you could choose a different structure that fits best to you. And that brings me to a small application, or that brings me to the code again. And then we could talk about a little bit of a book entity, for example, here. And just a second, so I need to check. Okay, so the first step when we're talking about an object model, we have to talk about the object itself. And we also did that when we talked about the primary key, foreign key constraint. So we do not need primary foreign key constraints anymore, but we need a unique identifier, right? So that's important. But what if there is no identifier? So for example, just a second, for example, an order maybe. So, or some other objects that hasn't an identifier. So for that, we always using a string, let's say string UUID equals UUID dot random dot toString. So this is a recommended way how we dealing with objects that doesn't have a unique identifier from the business side. Then we're using your UUID instead. That works great for us, and that prevents us from having duplicate entries or objects. But feel free to use your equals method or feel free to use a set instead of a list to create unique entries in combination. So feel free to use every Java functionality that helps you to manage your object model. So now, next question, and there is a lot more to talk about when we books, but I will come to that within the advanced training. But now when we move on with a book itself, so we need to find a storage for book, right? So, and the storage itself is a collection of book. And I already mentioned this. This could be a set, a list, and just a second. Yes, and we could store it, but instead of a list, so we talked about that million objects within a collection, and what about if we're doing something like this? Give me just a second. Let's say private. Is it? Oh, just a second. There's yeah. Let's do something like this. Map, and let's use a string here, and let's say we have a book here. Books equals new hash map, for example. What about this? Books too, doesn't matter. So what do you think about this? Could this a good solution? Hash map, what is wrong? Okay. Did I missed something? What's wrong? Come on, what? So this makes sense, right? So now, okay. So, but this could be also a great opportunity. So what could be inside the string here? It could be the ISBN. So that means we have one entry per ISBN, but it could also be a combination of ISBN, or it could be the first 3 or 4 letters of ISBN as your own index, you know, that enables you to divide these million books, for example, in smaller chunks, and you could managing lazy loading instead, maybe, or better searching on that. But to be honest, that is working great. So, and we did a lot of projects based on that structure, for example. But you also might say, okay, is there something easier? Yes, it is. And this is exactly why we invented the GigaMap for. And the GigaMap works totally different in the background because it manages the lazy loading stuff in the background automatically. But at the end, it's just a collection where you could add some one or more indices on that GigaMap, and provides you also adding special indices, for example, a Lucene search indice or special binary indexes and so on. There is a lot of documentation available and also examples on that. Yeah, feel free to try it out. So it's also available free and open source. Yeah, and I think the GigaMap is a real game changer to prevent stuff like this. But why not using that this way? It's much more efficient than the other. But when we're talking about lazy loading, I will get into a little bit deeper in that topic. Another question. So we have books here, right? So we have books here, and when we jump into the book, we see there is an author here. So, and now let's imagine we are selling the last book of a specific author. What happens then? So let's say we are selling the last reference holder of a specific author. We will lose that author, right? So that means sometimes you think about exact that case. What about your combo box that is filled with all the different authors you are providing? Or let's say you're selling the last book, and then you're getting, at the same time, you're getting new books, and you have to register that books in your database, and you need to find that that author that is deleted a few minutes ago. You will be in trouble, right? So, and that's exactly the situation, which works a little bit different with an EclipseStore, but it's also quite logical, I would say. Then we have to have another collection of authors here, especially for filling combo boxes and solving that problem. Sorry, author we talked about. So, and as always, I explain this also. Does this double the amount of RAM we use? No, it won't, because it's only references. So of course we have to pay for the reference itself. It costs memory, but sometimes it's necessary to have things like this. This is the only difference when we're talking about creating a data structure based on or for EclipseStore. Sometimes it's different, but at the same time, I would say it's pure Java. So do whatever you want, create your own data model, what you want. It's totally up to you how to structure your data. You could use hash maps and whatever, concurrent collections and so on. There is a lot of stuff, and it's the same on final here when we're talking about concurrency issues and so on. It's a topic for the advanced training. I will get into this more detailed about concurrency and how to handle it and so on. But at the other side, creating a data structure like this and feeling a little bit, it feels sometimes more complicated than before. You will get an insane amount of performance out of it. Okay, and performance, I would say, is the next hook for the next topic. I prepared a performance demonstration for you, just to give you a feeling what do we talk about when we're talking about using EclipseStore as a cache or as a storage, whatever. It's totally up to you. So I prepared a setup, and let me just check where it is. Yeah, here it is. So it's a setup that is also available on GitHub. And it's the following setup. So the idea is that we have two, let's say, EC2 instances or two server nodes, whatever. So on the left side, there is a Micronaut application with EclipseStore in it, and it provides endpoints, right? It's exact the same setup we created now. And to be more precisely, I guess I use it, the gigamap on the left side, as a storage for things. Yeah, let's see that later. And on the right side, we having one server node that runs a PostgreSQL server, and also a Micronaut app with Hibernate on an OR mapper in between, and also that provides REST endpoints. And there is a third server node. We call it a sender application. And when we click on a button, for example, these applications sends requests to these two server nodes. And in the middle, there is a Prometheus and a Grafana board, and it measures all the different metrics from the system. So the CPU, the RAM, access time, response time, and so on. That's the setup I created. Just to let you know, second. I need to find the links to the repository. Okay, it's in the MicroStream repository. So, but that's okay. Just to let you know, and I want to share the link with you. So this is the link to the repository, but you have to be careful. There are three different repositories. This is the performance demo sender application. You see, this is the structure behind the sender and so on. And there is a large description, and there is also a Docker compose file to help you to run this in Docker and so on, and a special description and so on and so on. So if you are interested in that, and I mean, it's also interesting to see how the gigamap works, because there is a gigamap inside of that project. Really great thing, I have to say. Okay, but let's jump directly into it. So I created a Docker environment here. Here it is. And it already starts. So you see that there are different servers I started. It's a Postgres server, Prometheus, Grafana, some for measurement stuff. There is a PostgreSQL database, metric export, EclipseStore, and the last one is the sender application. And when we now get into this, so after starting up all that stuff, we are able to jump into the first Grafana board. So this is the all the measurements and the metrics we need to see when we start the application. So just to give you a short introduction about this, the upper two boxes here are the CPU and the memory consumption of the EclipseStore application. And that's important. This is only the data provider. So this is the Micronaut application here. Then below, we see the CPU and memory consumption of the database, the PostgreSQL database. And to be fair, both applications, because when we compare EclipseStore to a normal relational database, we always have to see the memory consumption of the application server and the memory consumption of the database itself, because the two things belong together. And that's why we have two measurements here. The yellow line here is the database itself, and the green one is the data provider application. And I think it's vice versa on the right side. So green one is the database memory consumption, and yellow one is the data provider. And below there is some requests per minute and average response times we have. So nothing has happened currently. So it's automatically refreshing every 5 seconds. And that brings me to the next application. Let's log in. Yes, here we are. So that's the preparation, the sender application. And what we need to do is we have to create data at first, because we need to create data to calculate on it. And I think we should create, let's create 10,000 rows of books. Yeah, I think that's okay. So let's create 10,000 amount of books. So let's refresh this EclipseStore 10,000. We are ready. And we are okay. 1,000 and PostgreSQL database is still working, but this is okay. So EclipseStore creates it in quite fast, and so you can see there are some stuff is ongoing here because data needs to be stored, and that's okay. Nothing impressive so far. So let's check. Okay, so PostgreSQL is also ready. So we have now 10,000 books on each system. And then we have we have 3 different modes that we can run. First one is searching by a random title search. It's always a different title, so that it changes the title for each request. And this request is able to so it requests multiple titles, right? So there is one small search string, and that the response are a list of books at the end. And I think that is what we could start. So let's use the amount of threads, 1 per server, of course. We run forever, and we do not need a ramp up delay. And then we could click on start. So, okay, so now let's wait a short moment and think about what we have done so far. So both systems, right, are sitting on the same system. So on the same node, I have to say. So we have short ways. There is no delay in between data transition and so on. Everything is okay. Both applications are working in memory, because EclipseStore is by default an in-memory solution, and Postgre has its own cache, right? So that means there is a level 2 cache on the Postgre side. So both systems are working in memory in a way. Okay, so let's have a look on the metrics of the different systems. And please remember, when we're talking about EclipseStore as an in-memory data solution, we would say this application or this technology must consume more memory by default, right? Because it's an in-memory solution. Everything is in memory, right? So that's the idea. And when we now have a look on the metrics, so currently we are, so the EclipseStore server sending requests per minute 6,000, and so that's the request response time, and we have around 1,020 on the Postgres server. So, and that's quite interesting. So, because both systems have the same both systems have the same amount of CPU and memory. So that means every system has only one core, and you see PostgreSQL is using it for 100%, 60% the Micronaut data provider, and around 30% the PostgreSQL database, and EclipseStore is working on around 60% only. And you see that huge differences on the amount of requests we could handle on the Micronaut application compared to PostgreSQL. And at the same time, we're seeing that interesting memory consumption on both systems. That's quite interesting. That we see that EclipseStore is using much less memory, or so around 200 megabytes less than on the PostgreSQL data provider. Why is that? The reason, well, the reason for that is quite easy to explain, because the more concurrent user we have on an application server with a PostgreSQL and Hibernate implementation, the more level 2 cache you will have. And that leads you to the situation that you will have much more memory usage on an application server side by using Hibernate or a relational database than on any other, than on any EclipseStore native, because the object graph on EclipseStore is a cache at the same time, and everyone is working on that cache. So that means there is no session cache necessary anymore, and our object graph is the cache, and that's the biggest difference at this. And it's when you see the differences of how fast the requests are, it's enormous compared to any other system. This will change, of course, when we increase the amount of cores and so on, but it gives you an idea how much more powerful and cost-saving your system could be using a technology like EclipseStore for the right type of data. I think that's the message behind. So many people always ask me, is EclipseStore capable for handling terabytes of data? Well, if you provide enough memory, it will, for sure. But does this make sense? Do you really need terabytes of data always in high performance availability, I have to say? I guess not. And I think that's exactly the point. You should always find the right storage technology for the right type of data. And that's exact where we talking about nowadays when we talk about microservices and using different systems for different capabilities. Yeah, and I think that's the biggest benefit. Okay, so let's just change this or stop that test, and let's try the second one here. It's also an interesting one. We just need to wait until both system comes down. It refreshes only every 5 seconds, and now you will see both systems are going down with the memory and CPU consumption. And that's what I said when I said, okay, you do not have to take care about performance anymore. So it's in-memory performance is performance out of the box, I have to say. Okay, let's start the second run. It only it searches for a specific ISBN. It's a different indice here, and yeah, let's start this. and see what happens. And by the way, it's a little bit different when we inserting data, because we talked about this. The insert is always a blocking operation. It needs more time, but at the same time, you feel free to add your own thread, or you wrap in an own thread, and then you will have your own non-blocking stuff. But at the other hand, you will get an eventual consistency based on that. Yeah, it's a trade-off, but yeah, that's okay, I think. So I think we will get barely the same result, but due to the fact that we only have one result, and you see the amount of requests compared to the PostgreSQL. So we are having 19,000 request responses, or 24, or it still grows. So I have to say the PostgreSQL server performs okay. So, but on the other hand, we are on around 272,000 compared to EclipseStore, and so I have to say that one of the biggest things is what the amount of performance you get by consuming less CPU and less RAM. When we see that here, that's incredible. Okay, so I hope that gives you an idea of the performance and also some metrics. Feel free to check out that project and see what's going on inside, and maybe start it on yourself and give us feedback. That's important. If you find something you see, okay, that you should handle differently, or you should add something. I mean, you could always improve things always. The GitHub link is right above your comment. So it's a microstream perf demo sender, and there are 3 repositories: one for the sender, one for the Postgre Micronaut implementation, and one for the EclipseStore implementation. So check it out, give it a try, and yeah, feel free to improve or give us feedback on that. So that would be great. Okay, so let's move on. So I do not need this anymore. So let's stop Docker here. So this is also gone. Next topic, lazy loading. That's an interesting topic, and therefore I also brought a PowerPoint presentation. Here we are. Yeah, lazy loading. So the question is that we have to clarify: why do we need to store and load data in a lazy way? That's for some of you it's quite obvious, but sometimes it's a good question, because why to use an in-memory database when we have to load a lot of things lazily after? Then we will lose a lot of advantage, I would say. But it makes sense to have this. And we have to clarify what data should be stored and loaded lazily. And there are always different types. And how to use it, of course, is important. And some best practices. And we also have to talk about how to release already loaded lazy stuff to make it no longer available to release memory, I have to say. Okay, so why lazy references are important? Okay, basically, EclipseStore is an in-memory database framework, and that is one reason why it's so fast and performant. That means you will get best performance. For best performance, data must be in the RAM, of course. But it's not always possible, especially when we think about binary data, images, documents, whatever. So it makes always sense to have this data or keep this data on your hard disk. And to be more precisely, from my point of view, I would also always recommend you should never have this data within your database. The reason for that is easier. Whenever someone calls that binary data, it always goes through your application. The stream goes directly through your application. That is always quite a mess, because the more people concurrently accessing binary data, the more heavyweight data is streamed through your application. And that nowadays we have some other technologies like AWS S3 bucket or whatever's the solution on Azure, or yeah, use binary storage whenever whenever it's possible, and then these heavyweight traffic is managed right through right beside your application. So, and that is a huge benefit on having some such systems like this. But in case if you need to store it, it's totally okay doing that. Use EclipseStore for that, and it works really great. But you have to handle this in the lazy way. And sometimes, yeah, it's just unnecessary to hold all the data inside the RAM. That's also quite clear. When we're talking about archive data, or yeah, some data which is not needed all the time, once a month, for example, or whatever, it makes sense to keep the data on your hard disk. And this also is a big point for, let's talk about, we have the history of the last 20 years in our database. That's great, of course, but it's so much expensive, because you do not need the last 20 years. Maybe it is enough having the last 5 years in focus. It's not possible for everyone, that's quite clear. But for a lot of people, it makes sense to archive that data to somewhere which is much cheaper than your database. And this leads you also to the situation where not to search within millions of data all the time. Sometimes make it easier. And after, let's say, after one row reaches an age of 5 years, it goes automatically to the archive. And this leads to a constant workload on your application. So, okay, in short, we need to decide what should be loaded lazy way and what should be loaded at database startup. So, and that brings me to the default behavior of EclipseStore. When we have an object model like this, and let's say we have 100 millions of objects here, and you see we have 2, 1, and 1 again here, and whatever else. At startup of EclipseStore, this will be loaded to the heap, to the memory. And that's important. So, so we need to find a solution how to keep things smaller in the memory. And that brings me to the point where we are able to set some lazy references. And you see that, I think that's also a key of, you remember that huge list of books, for example, we talked about 10 minutes before. And it's not always to take care about, let's say, adding a lazy on top of a list, because at that moment you have to stream through. You always have to load the whole list. So, I mean, it's okay doing that. But on the other hand, you might say, okay, so if the list is touched 10 times a day, this list will stay in the RAM anyway. But on the other hand, you always have to consider if a collection is touched, let's say 100 times an hour, then this collection needs to be in memory. And at the other hand, when we think about the more concurrent user you have, the more data will stay in your memory anyway, because different users doing different things and loading things and so on. But the good thing is that we are able to setting some lazy endpoints on the relations. So that means when we're talking about here, we're talking about, let's say, this is a customer, for example, and the customer has a list of yeah, what can we do here? A list of orders, for example, or a list of products, whatever. And that list of orders could be handled the lazy way. That means it stays on the hard disk at startup, and we will be able to fill grids and whatever based on user or customer data. That's totally fine. But at that moment, we are loading, we need the orders of a single customer, then that, and we could use the get method and load the lazy parts of it. And I think that's the idea behind lazy, using it within your object model instead of covering huge collections on that lazy. For that, we provide a gigamap and hash maps and so on. But lazy is more powerful on the at the object graph nodes and relations, I would say. Okay, so this is how it works. Lazy, and lazy itself is working as a wrapper. So when to use it, as I already mentioned, always on binary data. So on blobs, documents, images, whatever. And I would also recommend it using it on huge collections, like with less frequented data, let's say logs and archived data and so on. And sometimes on collections with huge amount of sub-entities. Yeah, that's always, I think it's not that important since we provided you the gigamap. That makes things a lot easier. But for now, it's always a thing that you have, it's a decision that you have to make at the end. You always have to, how many people are working, how many concurrent user do I have, and how frequented is the data, and so on. It's up to you to create your own object graph. And whenever you want, if performance isn't that important, in this part of data model, or if the amount of RAM is limited. Yeah, okay, I think that's quite clear. So this is the way how it works. So we are using lazy here as a wrapper class, and it wraps the original data type here. And in the same way, we having this here, we already talked about that structure, let's say hash map. And do you remember the first 3 or 4 digits of our ISBN, or let's say the first digit of our ISBN as an index in the key? And then we have a lazy list of books, for example, or a lazy byte of a specific image or document or whatever. So, and the string could contain, let's say, the search index for seeing what's inside the image name or whatever else could be inside here. I think you get the idea. To load it, you always have to call the get method. So at that moment, for example, book.getImage, you will get the lazy reference. And on the second call get, this image will be loaded from your hard disk or from the AWS S3 bucket, whatever. That's one solution. Then we have to talk about this one. So I already mentioned this. This is a list of books, which is wrapped into a lazy segment here. But as I said, the problem here is that of course, this is the easiest way to handle this. But at that moment, we have to search through that list. We have to load it. We have to load the list at once. And that's one of the major differences to the gigamap. Gigamap is loading that stuff in chunks. So, and it releases it automatically. But the interesting part is how to instantiate it. So lazy.reference, and then you have to add the new array list of books. So this is the way how to instantiate. In my opinion, this one is a great opportunity having this on another side. So it's also great having just the book as a lazy reference. But then you have to be a little bit careful. You have to be careful about this, because sometimes the lazy reference itself costs more memory than the book itself. It depends how big the book is. But yeah. Okay, let me just check. There are some questions in the chat. What kind of statistics are collected about the object model usage? Is there any default solution? Unfortunately, not. There are small statistics, but if you need to have all the informations about what's going on inside, I would prefer the oh, that's I hope so I could not remember that technology. There is a standardized technology to monitor Java native stuff. It's J, 3 letters. I can't remember. It's a standardized monitoring and metrics solution for Java. J. Yeah, maybe I remember a little bit later, but this is I think it's the same technology, JMX, right? Yeah, thank you. And you could use this for monitoring everything within your object graph and within your memory. I think it's the same technology that is used by a Visual VM or stuff like this. And I will come to that a little bit later. Okay, and there is another, in case of a large binary data like an image, the file is always fully loading before it is accessible or it's streamable. That's an interesting point. Yes, it needs to be fully loaded to be accessible. That's right. Yeah, that's true. But that's an interesting point. So that brings me to a feature request that would fit great for make it streamable. Maybe it is streamable, but yeah. Let me take this with me. I have to ask my colleague for that. That's interesting. Okay, but hopefully that answers your question. Next step is we need to talk about how to release loaded data. And therefore, oh, come on, that's a great presentation. So, so the easiest way, or you could do it the manual way. So it's what has happened here. So you could always use the clear method on the lazy reference itself. So lazy image is the lazy reference here, and the get is to get the binary array, and to release that you have to call lazy image.clear. That clears the reference, but of course, to see the result of the released memory, you have to wait for garbage collection. So that's why I added the system.garbage collection, and that clears the memory automatically. That's the manual way. And I have to say this is possible. And maybe this makes sense at the moment when you upload bigger files, for example. So you upload something, you store it, and then you could immediately take care about clearing this to keep the memory free, let's say, because at the this would also work, right? Yeah, exactly. That does the same trick, because the default behavior of the lazy reference manager within EclipseStore works on different mechanics. So that means whenever an object is untouched for 30 minutes, it goes directly. It will also be cleaned up automatically. That's one functionality. And the second one is if the memory gets over 75%, then also EclipseStore takes care about for releasing the older ones. That is the default behavior, and you will always be able to adjust this. So that means you could add a smaller duration or whatever. So it's totally up to you. Okay, so this is how it is released. And that's it. And I would say with that knowledge, let's jump into a project I prepared for you. Let me share this with you. And this is also just a project to give you an idea how EclipseStore behaves in the background and to create trust on your side. So to see if everything works properly. Okay, so I need to find, so many stuff is opened. So here we are. Yes, here we are. Okay, so that is the link. You. Oh, maybe I made a mistake. Sorry for that. I sent a message to as a personal message. So you ask for the repository for the performance demonstration. Okay, here it is to all of you. Sorry for that. I sent it to as a private message. Okay, the first link I've sent is the lazy demo. So it's what we're doing now. And the link above, so the microstream performance demo sender application, that is the right link to the performance demonstration we see a few minutes ago. Exactly. There is one lazy reference manager per storage manager. Exactly. Only one per JVM. That's right. Okay, so let me clean up this a little bit. Do not need to save. So, and normally, this is an example I normally use within the advanced training, and therefore there are several branches and so on, and we have much more time doing this, but feel free to do whatever you want. So I want to go through the different branches for a short moment. I want to explain what is the idea behind. So you see there is one branch which is called step 1, change to lazy. So that means when we first go to the master branch and when we have a look to utils db data root, for example, we see there is one list of persons, and when we have a look at the mockup, you see there is a person JSON. You see that and this JSON has 1,000 persons, and I created persons with a lot of data in it. You see that there is multiple big strings in that person data, and every time we click on create persons, for example, that will automatically be loaded into the storage. And that's quite interesting. So, and we using a normal list of persons. So let's do so. I just need to start the visual VM. And now this will lead a little bit into a heavy window management session. So don't be afraid. I will take care of it, hopefully. So, okay, application visual VM is there. So I need to get back to my IDE. Here we are. And we are on branch 1 master. And let me just start this. So let's do a Maven update first. That's okay. Then we have to check if there is a storage already available. No storage so far. So let's start an application. It's kind of research what we do now. Okay, start is complete, storage is empty, nothing is special here. Let's have a short look into the controller class. So there is one create, and what this one create method does, it creates 200 times that mockup data here. So that means when I call this, it creates 200,000 rows of person data. And that will be interesting to see what's going on in the RAM. So just to let you know. So application is up and running. Now we should see the application here. That's the application itself. So now click on this, and now we see the different CPU usage and so on. I think the interesting part is just we do not need CPU, right? So okay. So CPU is not that important. Classes, yeah, maybe, and thread, let it like it is. So we see on a basic startup, so the yellow part or the orange part here is the heap size, and the blue part here is the currently used heap, what we have. So now when we, I do it on my second screen. So when I now call localhost 8080 books.create, I guess this, or customers, let me just double check. So persons dot create. And now I hit the enter button. Well, now you should see what's going on. So now the 200,000 rows of persons will be created. Okay, now person successfully created, that's it. So now we stored 200,000 rows into the database, and let's perform garbage collection, and we see that the memory consumption for these 200,000 elements are, yeah, around, what is that? 1.3 gigabytes of RAM. The interesting part is how big is the storage itself. So when we have a look to the data here, so now let's say right click, show in System Explorer. Let's go into data. So when we now check this, right click, and so, and you see it's nearly the same. So we have 1.53 gigabytes at the moment. And yeah, it's close to the memory consumption. So I would say it's, yeah, in a way, one by one. The memory consumption on your hard disk without lazy will be in a way the same that it needs within the memory. I would say a little bit less, let's say 80% around. So, and we could click again on the next one, refresh, then we should see the next 200,000. Yeah, here we are, 400,000 now in the storage. And this is the default behavior, I have to say. So I think nothing surprisingly here. But when we now stop the application, and that is exactly what I want to show you. So especially in that case, it's a list of persons. When we now start it again, we will see that here we are, right click, run as Java application. And there is one, so just this method here, init microstream, just initializes the storage itself. So when we now, this is, we don't need this anymore. Monitoring, CPU is not needed. Okay, now I want to call that init method. And in that moment, you see that 400,000 elements will be loaded again on initialization. That's exactly what I told you in my presentation. Without lazy loading, at application startup, the data will be loaded. And now we are talking about around 3 gigabytes of data. And it's the same on the hard disk. Okay, so nothing really special so far. And now we could go on. So now we could say, okay, let's change this behavior a little bit. So, and that brings me to the next branch. And I will skip some branches to save some time. Let me just, so that, so I need to delete the data here. Right click, switch to, so switch to. So now we could change this to lazy. Change to map. Yeah, let's do so. So let's change this to map. So and now that's a different situation. So we have one map instead of a list. And now we are using lazy references on the person here. And within the string, so let me just check what's inside the string here. When we go to add person, it puts the UUID of the person plus the last name as a key value here, and the person itself, it's lazily handled. So let's try this, right? So that is, let's see what is the change or the outcome at the end. It's the same amount of memory, and I just need to check. You see that the business logic is a little bit different. Yeah, but it is okay. So in it, it's the same. Okay. So let's start this application class. Right click, run as Java application. So this is not needed anymore. We need the new one. Monitoring. Okay, same situation here. Let's create persons. Was it create? You see, initially it runs the same. It needs slightly more RAM or more memory consumption because of all the data overhead because of references. We always have to calculate the lazy references and so on. It's more, but when we use perform garbage collection, you see it goes down to the, yeah, let's say barrel, so nearly the same amount of RAM that we have. So when we now have a look to the project itself, we see data, and one of the interesting things is, so we see that the lazy reference manager here is set to lazy checker duration of 1 minute. So that means after 1 minute, if the data stays untouched, it should go out of the RAM, right? So, and now we will exactly check this. So we loaded the data here. It's 1655. So now we are right here that we could perform garbage collection here. And now we will see, hopefully, no, it's a little bit longer. Maybe it clears it step by step or something. Just yeah, it goes down. It clears the references step by step out of the memory. But this is, you see, EclipseStore releases that stuff. It is, yeah, the housekeeping is thread safe. Yes, it is. So, and you see data is going down, down, and down. And it releases all the lazily loaded elements automatically. One more interesting stuff is, and maybe another interesting stuff is, let's try to find a specific person, for example. So there is a controller, and then we have get persons. Get set string, get persons. Yeah, let's try this. What happens on the RAM when we now call the getPersons method? So you see, this is the data, not well formatted, of course, but this is the data of that 200,000 persons, and I could refresh this. This is only you remember the key values of that persons, and it's the UUID and the last name, I guess. This was the contract. And you see what happens on the RAM. Yeah, nothing, I would say. So because it's in memory anyway, and so that means most of the data stays on the hard disk because lazy is not loaded. It's a little bit of a shame. I hope there was one method to load a specific person, but it's not there. But anyway, so I think it's you get the idea of lazy loading. You could use it this way, for example. And I have to say there are a lot of more opportunities of using a lazy loading. For example, when we switch into the next branch, multi-maps, or let's use full lazy map, multi-maps, for example. Maybe it's interesting for you. So especially in that example, I created a class which is called persons, and that person contains multiple maps with different indices. For example, persons by last name, persons by mail. That might seem a little bit complicated for you, but as I said, if you need this, if you need to have millions of data within your application, and this solution leads you to getting that data in a really fast way, then why not doing this way? It's up to you creating a structure like this. And let's move on to another branch. Full lazy. I think that was this is my favorite. Yeah, that's my real favorite. It's a really straightforward. It's a little bit in the same way the situation we had before. So lazy person here, a string, and that string contains the email and the UUID. And as far as I remember, there is one. Yeah. This is where we need to stay. So there is one method. I could search for a specific person with a specific mail. And let's do this. That could be interesting. So yeah, I deleted this. Just to give you an idea how fast it is working, even if we're not using the gigamap, for example. So need this just to ensure that we see what's going on in the memory. So, and on the basic, as a basic step, I want to create some persons. So person/create. Let's create the first round of persons. Okay, created. And let's create another round. No, it doesn't. No, it's not in parallel. Oh, CPU. Yeah, of course. Here. So that's the CPU. And to see what's going on my browser here, persons create, I just click on refresh and it sends the requests again, and see it grows more and more, the memory consumption. We are at around it isn't working in parallel. So it is created. Now we have 600,000 persons in the storage, and I'm not sure if I added a specific lazy handling. Okay, after 1 minute, so let's wait a little bit. We should see that the memory consumption goes down. And based on this, so now we could call that mail, but the interesting part is we need to see what mails do we have. So let's use this one, for example. And How is the endpoint working? It's always not that easy to person controller here. Mail, and it's a query value. So how to call this? I think I have to use the Postman for that example. Yeah, here we are. So find person. Person's mail. Yeah, that should do the trick. So, okay, so let's have a short look, perform garbage collection here, see what's going on the storage. So it goes down again and again. I think the interesting part is to see what's going on if we search for a specific mail. And therefore, I created that postman stuff here, and I could send. And you see, these are the return values of course, there are multiple users with the same email address because we click on again, and it's always a fake data. But you see, these are the results of searching within 600,000 element, and how fast it returns the data. So let's choose another email. Just to let's use this one and add this. Oh, that's the wrong one. Here we are. As I said, heavyweight windowing. So quite cool, right? So 24 milliseconds, that's quite fast. Getting the result out of that. And you see there are exactly 600 because there are 600,000 entries, and it's quite great to see the performance. And yeah, all over. To close that topic for now, it's the idea how to use lazy the lazy reference and lazy references. And okay, so questions. It's time for your questions. Housekeeping, thread safe, parallel. I think we clarified that. Okay, so no questions so far. Oh, it's late a day, right? So it's now it's getting difficult for the last 30 minutes. Okay, so lazy loading. There are two topics left. One is the legacy type mapping. It's a quite easy topic. And let me just clean up my windows a little bit because it's quite confusing having such a lot of windows here. Okay, so legacy type mapping. So that's always an interesting topic, because what happens if some Java classes changes? And that's really an issue, because but not more an issue than having the same situation on a relational database, because it's working quite the same. I created a project, and I'm going to share this with you as always. And we only doing the light-white legacy type mapping because the heavyweight stuff comes in the advanced training. So this is the link to the GitHub repository. And also in that project, there are different branches. So, and we starting on the master branch. So that's the first branch. We want to see what's going on. So, and we see it's really straightforward. There is one domain with an author and an author controller, application DB, the same setup like always. And there is one class which contains a string, mail, first name, and last name. That's it, right? So, okay, so there is no storage so far. Yes, there is one. Let me just delete this storage. And let's create this. Let's start this right away. So there we are here, application, run as. Okay, let's check the controller. So let's create some authors here. Localhost authors, right? Author/create. Okay, you see that the storage is initialized and I get the message author successfully created. And let's check if they are available, and that's exactly the case. So when you now have a look on my browser, here you see there is one author created with a mail, with a first name and a last name. Okay, so good so far. Oh, so far so good. Now, let's keep everything as it is. So there is a storage created, and let's refresh this. You see there is data, and now have a short look to the type dictionary before we change. So when we now scrolling down, we will see that there is one object in the exact same way that we created here. This is our author. And you see that there is an object type ID, which is here. And when we now could look into the binary part of the storage itself, we should see that every element or every object in the storage consists of an object type ID, which is this one, and an object ID. So this is the object ID for identification of an object. So, and that type ID, that's the interesting part here, because when we now, let's close this, and when we now changing the branch, new team switch to changes stage 1. Now we should see that the author has changed. Now we see that there is the name of an attribute has changed, and also we could see this here. So this was the old one. So before the name was mail, now it's mail author. And then is there another change? I think it's only the mail author stuff. And a last name changed also from last name to name. And when we now start the application, some interesting stuff is going on here. So the application itself reminds me that someone has changed. Oh, I have to initialize. Okay, you see that? This is the legacy type mapping that now works. And there is an algorithm in the background that checks the author object or all the objects, and it based on a special heuristic, it sees that something must be or has changed on the author, and it says, okay, this is the old one, mail, and it guesses that a 70% chance that this author is just a renaming to mail author. And it says, okay, so first name, no changes at all. So that means 100%, that's okay, that's the same. And it's the same based on name and last name. And it guesses by 75% that only changing the name. And this is, by the way, working for all the different changes you could do. So renaming, changing the place of so the position of the field within the Java class. And he asked me, am I okay to accept the mapping? And I said, yes, that's okay for me. And when we now call the same method again, we should get a different result. You see that? Now it is called mail author name instead of last name, and it is changed. And the interesting part comes now. When we now have a look to the persistence type dictionary again, it changes. And you see that here. So it creates a second object based on the changes we made, and its domain author. And now with the changed elements. So what does that mean? So the point is, EclipseStore works kind of like behind the scenes. There is kind of like a versioning working. So the first step is to map the object to the right values. This could be done by the heuristic automatically. That's what we did. Yes, we did now, and behind the scenes there is a versioning. That means whenever you touch an object, it will be automatically transferred to the newer version, and all the untouched object stays on its version whatever. So that means at the beginning we thought about, okay, on startup updating all the objects and so on, but this was not possible. And at the end it was by far more effective using this type of versioning and only transfer the objects to the newer version at the moment the objects are loaded. So this is, I have to say, this is the first part of lazy loading. When we so I also prepared a small presentation. We do not have to go into it fully, but it's interesting to see. So we already talked about this. So these are the different possibilities of changes that could be handled by automatically. So you see, it's a reordering of the fields. It's changing the name. In some special cases, it's also possible doing some changes from, let's say, from int to integer. So that means whenever a data type transition could be, or a data type migration could be done automatically, it will at the end. But if not, we have to talk about a different solution. So it also noticed also adding a new one, for example. This is also possible. So you could add or remove something. These are all the stuff that could be handled automatically. Does it mean the old object cannot be loaded in case of what? If you removed it, or you mean if the transition is made? No, you will not be able to touch it anymore. The old version, to be more precisely, the old version cannot be used anymore. So at the moment you did the transition from old one to new one, and to start it, then you will not be able to load the old version anymore. So because it will automatically be transferred to the new one. But this is quite obvious because the Java virtual machine will not be able to handle outdated objects, because there is no Pojo anymore that could handle that type of object, right? So and therefore it must be migrated to the new one. Two questions we have to answer. The first one is, what about let's say heavyweight data type changes? Let's say we change something from string to big decimal, for example. How could this be handled? I mean, does it really make sense doing this? But let's say string to integer or integer to string, whatever. So the answer is it is possible, but there is no embedded functionality that handles this, because it relies always on your own business logic. So a best practice how to deal with that is to create a new field, start up the storage, then transfer all the data to the new field, and then delete the old ones. So this is what we mostly do when we doing upgrades. But on the other hand, I have to say, how to deal with that on a SQL Server database or relational data. I think it's in the same way or in a different way complicated dealing with that. It's always hard to migrate data, I have to say. So that means the lightweight stuff could be handled mostly without any problems. But as always, please do or create a backup of your storage. That makes totally sense. Okay, there is a lot more regarding the legacy type mapping. And when we jump into the documentation, you see there is one section of legacy type mapping, and there is a lot more to know about the legacy type mapping. People are always asked, is it possible to use a strict mapping, or to define your mapping by yourself instead of using that heuristic? Yes, it is. You could create your own file, an explicit mapping, we call it here, and that enables you to create a file that looks like this one. So the refactoring CSV file, for example, and this enables you to very or explicitly define the way how objects should be transferred from one to another. And that brings me to one question directly at the beginning of the training. If it makes sense to store third-party objects. And that's exactly the point where things are becoming difficult, because you never know what change on a third-party library or object, and there might be some situation that object is moved from one class path to another or whatever. And when we jump back into the persistence type dictionary, you see EclipseStore relies on the full qualified class path of an object. And this could be an issue when you're using third-party libraries or third-party objects, in case of that third-party company changes the location of the author object, for example. It's not a big issue, but you could directly jump into persistent type dictionary and change the name directly here. That is possible. And then this will work fine, but you never know what else could happen on a third-party object. And that's why you should always be careful with third-party objects within your storage. And I would not recommend storing third-party objects. Okay, so, and as I said, there is a lot more to know regarding that legacy type mapping. More comes on to the advanced training, and that brings me to the last topic for today before we close. It is the way to access via the REST interface. And I will do this. There is one example projects, and I have to share this with you because it is called client UI. Yes. Here is the link. Client UI. Okay, so that's the project itself, and I do not want to start this because it's some stuff like, but let me share this with you within the documentation. And you could find this in that REST interface section here. There is an embedded REST interface, but the important thing first, it's only for development purposes. It's not for production, because there is no security stuff or anything. Just use it for development purposes. So, and you have to enable that REST API, and this is possible by here setup. You have to add the dependency that is needed, and then yeah, that Spark REST service needs to be enabled. And when you now create the embedded storage manager, here is the line of code that needs to be added. So the service starts after initializing the embedded storage manager. And this service enables you to access via the client UI that we provide. So it's the client UI is available here. So it's you can download the standalone application. It looks like this, and you could start it directly. And with that application, you are able to access to your current running storage. And it looks like this at the end. And this is what I told you at the beginning of the training. It's always a graph. It's not that nice visible thing that you expected when we're talking about, for example, the PG admin or whatever. It looks a little bit different and more complicated, but it gives you an idea how the data lives within your object graph. But it's quite hard to visualize that, because a graph like this could be endless sized, and it's quite heavy to create a nice looking interface on that. And from my perspective, or in my experience, I used EclipseStore now for years now, and in several projects. I used this interface once or twice at the beginning, just to be sure if everything works then expected. But nowadays, you see that I mostly create my own REST endpoints to see what's going on in the storage, to check if everything is working than expected. I do not use this anymore, but and I'm really used to the point is, I guess, at the beginning when you start with EclipseStore, you feel quite lost because you never know what's going on in the storage. Is it stored? Is it not stored? This feeling will go away for sure with the time you are experienced in using EclipseStore. And it's the same on me, due to the fact that you always work on your object graph, and you know the structure and you know what's going on in your application. That leads you to, yeah, you know what's going on. So you will not need this anymore. And to be honest, you will create your own REST interfaces to provide it to the consumers, and then you have the list of elements on objects anyway. So you will not need a database interface anymore. But for those of you who want to try it out, feel free to do. We are still working on that to improve, but also, to be honest, it's not the highest priority, I have to say. Okay, so that brings me to the end, and there are still 12 or some more minutes left for your answers. So feel free to ask. I think I talked a lot in that training. Now it's your time. Try to answer the last questions. I will also share my email address. So for some late answers, feel free to contact me, and I will do my best to answer this. Microstream.one. So that's my email address. So let me know if something goes wrong when you try out EclipseStore and you have some problems. Let me know. There is also the GitHub discussions for those topics to see what's going on. So. Thank you. Yes. So last but not least, let's go to close this. Let's go through the topics. So EclipseStore introduction by Marcus, check. EclipseStore quick demonstration, check. We done step-by-step configuration, check. We did this. We talked about CRUD operations, also a check. We talked about creating a proper data model and the different possibilities of handling an object graph, check. Optional Java streams, well, yeah, a small one. Lazy loading, yes, check. EclipseStore client UI, REST interface, that was the last topic, and legacy type mapping, check. I think we did most of the topics, and now it's pretty late in Germany. I would say it's 9 p.m. It was a long day, so could you a bit about one of the projects where you use it? Of course. So we are using EclipseStore in my area. We are using it on the Allianz Insurance Company as a normal, straightforward storage within the sanction how to call it sanction review section. So and we are also using it on the Fraport German airport. They are using it on the baggage handling system. So whenever you bring your luggage to the Frankfurt airport, it is handled by EclipseStore in the background as microservice databases for covering a big monolithic Oracle behind. It is working kind of like a cache, but not only a cache. There are some microservices that so the point or the idea is when we putting a cache in between Oracle database and the application itself, then the application becomes more and more just a backup, right? So because the cache is handling all the traffic at the end. And sometimes it makes sense to bring it to the point and say, okay, let's remove the data out using the native backup functionality of EclipseStore. That works great. And using that former cache as a full storage. And we are also using it on Android devices instead of SQLite. Yes, and there is a lot of more things going on. Yeah, the biggest application that we now create are around 200 gigabytes of data, which is provided all over the world. We have, I guess, 24 countries that consumes the data, and there are around 600 or 800 concurrent users on the system, and it works great with a really small engine. Really great. And yeah, that's only the project what we used for, but there are 1,000 different possibilities to use. GigaMap production ready, I would say yes. For now, I'm not aware of any big issues for now. So we fixed a lot of issues in the last few weeks and days. And I think we're still working on some issues, but I don't really know if these are corner or edge cases or whatever, but I would say yes, it's okay to use it. So I couldn't find any issues so far. You see that also the performance demonstration is running on the GigaMap. Just give it a try. It's free and open source. Try it out and see if it runs okay for you. It's always surprise. It's always also a surprise for us to see what people doing with an open source technology, because we met them and they said, okay, I'm using Jetstream. It was the former product for years now, and they providing data. But it's always quite funny to see what people build on that. So feel free to try it out because it's open source. It's a great technology, and yeah, use it and it will grow, of course. Okay, so that brings me to an end, and that brings me to the point where I have to say thank you for joining the fundamentals training today. I hope it was interesting for you. And as I said, try it out and bring some more questions to the advanced training. It would be a great pleasure to me to see you again at the advanced training. And yeah, enjoy the day. And I would say happy coding. Thank you, and bye-bye.